Active Directory class. If you have taken a Microsoft Active Directory class, you know very well what LDAP is, Lightweight Directory Access Protocol. LDAP is the search and edit protocol for X500 style directory services. It is way beyond the scope of this class to get into Active Directory or X500 directory services. If you're a little rusty on that, please look it up real quick. So just do a quick overview. Don't do a deep read on that. If you have taken a Microsoft Active Directory class, you know very well what LDAP is, Lightweight Directory Access Protocol. LDAP is the search and edit protocol for X500 style directory services. It is way beyond the scope of this class to get into Active Directory or X500 directory services. If you're a little rusty on that, please look it up real quick. So just do a quick overview. Don't do a deep reading. LDAP is the protocol we use to query those databases. So let's go take a look here. LDAP enumeration. This lets us access distributed directory services. We query the database. Now, directory services are organized hierarchically and logically in a logical structure. They follow something called the X500 or the X.500 naming convention. This is an ITU convention, I believe, yes, that means that everything in the whole world ultimately has a unique name. So I have the domain, child domains, organizational units, and then leaf objects like users and groups and computers. So like I said before, pretty much any Active Directory user has the right to query anything out of the Active Directory database, unless it's something restricted like a password hash or certain policies. But every user, group, computer name, regular policies, I can just dump them. Users have the right to query that, amazingly enough. And we can use LDAP. So Active Directory is but one tool or one service that uses it. Microsoft Exchange, which of course is Active Directory based, uses it also. You probably have other directory services. There was Novell. You can have LDAP directory services also in Linux. So the client will start an LDAP session, and it connects to a directory system agent on TCP 389, and it just sends requests. So you too, as an attacker, can query LDAP to get, well, pretty much anything. All you have to do is bribe Susie Q with a chocolate bar or something, or chat up Moo in the bar, buy him a drink, and get the username. Or get their business card and just figure out from their email address what their name is. In Active Directory, chances are excellent that their email address is their login name. So then from there, we just have to figure out the password. Won't take too much. So the naming hierarchy for X500. Now, this is, like I said, not an Active Directory class, but there's a hierarchy here. So we've got something called a domain component, like org or com or net or mil or whatever. And then scrolling down underneath com, you have example or Microsoft or CompTIA or EC Council. Well, EC Council would fall under org. And then the organization, this is what we call not the top level domain component, but the regular domain component. From there, we break out into organizational units. So maybe this company is broken out into people and servers. So organizational unit is it's the functional equivalent of a folder. And then underneath people, you have various user accounts. And underneath servers, you have various server accounts. And it just kind of goes like that. There are a number of LDAP tools. So there's Softera, and with a bunch of details that you don't need to memorize. There's Active Directory users and computers. There's ldp.exe. So like if we zoom in on Active Directory users and computers, this is the classic look here. We've got the domain, and so here's the domain here. There are some containers, which are basically folders. They're just things to organize stuff inside the directory. And so we've got built-in, that's built-in accounts. We've got computers, we've got domain controllers. Foreign security principals are people from other domains who are trusted. We've got users, and so when we click users, you can see like a whole bunch of users and groups here. Classic Active Directory.
What's going on YouTube? This is ippsec. I'm doing Ypuffy from Hack the Box, which was a really fun box, and a lot of people asked, why the name Ypuffy? My guess is it's just because it's an OpenBSD box, and the OpenBSD mascot is that blowfish, and his name is Puffy, so I'm guessing that's where the name comes from. The actual exploit path of this box was pretty cool. It started off with scan, you see HTTP, LDAP, and SMB. You notice that LDAP is misconfigured to allow anonymous binds. You do a dump on LDAP. You notice it actually gives you the NTLM password hashes of users. You can do a pass the hash against the SMB service and get the
this is Paula Januszkiewicz, or Paula J. Welcome to another episode of Secure Hacks Weekly. This time we're going to be talking about the most popular attack, which is pasty hash. First of all, what I need to say is that every single time when we are doing penetration tests, pasty hash is one of the elements of the whole test. And the reason why it's like this is because pretty much every company doesn't do anything about it, while attack is popular for the past couple of years. In this episode, I will show you how to perform the pasty hash attack, what are the preconditions for it, why managing local administrator passwords is so important, but that's not everything. Why, for example, logging on with privileged accounts to workstation servers, it's also something that we should definitely pay attention to. And to the whole thing, I will use the tool, which is quite a unique tool by our team, which is not recognized by antivirus, and the link to it you're gonna find on my blog. Okay, let's dive in. Okay guys, so you should see my screen right now, and let's perform the pasty hash. As you may know, in order to perform the pasty hash, you have to be a local administrator. That is because of the debug privilege that we need to have. And on my screen right now, you have two consoles opened, one as a user, another one as an administrator. So of course, just to show you, this is the console running as an administrator. We can spot this already by a list of different kinds.
At the end of a simulation, I'll show you, step by step, how to perform the pass the hash technique with Metasploit. Pass the hash allows
private key to log in via SSH. When you log into the box and check its SSH configuration, you'll notice that it's actually checking a certificate authority to see if that authority signed SSH keys, which is unique. And you can do a doas command to run as the certificate authority user, so you can sign a SSH key, say it's from the root user, and then just log in as root. If you didn't poke around the SSH configuration stuff, there is another way to privesc via a CVE. I think it's in the xorg package. We'll also do that. And before we get into this, I do want to give a shout out to Recon InfoSec. They run a lot of the Blue Team villages for allowing me to use the Wireshark image that's actually a sticker. And the link to the store is in the description below. And you'll understand why I'm including a Wireshark image in just a second. So let's go into the box. As always, we're going to begin with a nmap, so nmap-sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it ypuffy, and then the IP address, which is 10.10.10.107. Can take some time to run, so I've already run it. Looking at the results, we see a few ports are open. We have SSH on 22, it's running OpenSSH 7.7, we have HTTP on 80, it's running OpenBSD HTTPD, which is a new OS for us. We haven't really done any enumeration for OpenBSD before. And then we have SMB on 139 and 445. And finally, LDAP on 389, and it allows anonymous bind, which is unique. But first, let's just try to figure out which version of OpenBSD this is, and we can do this by just finding out when OpenSSH 7.7 was put into OpenBSD. So let's go to Google, type OpenBSD, search OpenSSH 7.7. Go here, and then just scroll for 7.7, and we see April 3rd, 2018. So let's just search for OpenBSD release history and see when each version was released. So we have these threes. So we have 6.2, which is 9 October 2017. We have 6.3, which is 2 April 2018. And I think this is the deprecated date or supported until. So chances are it's not 6.2 because OpenSSH 7.7 came out after this. Oh no, it came out before this. I misspoke there. Ignore what I said. Anyways, 6.2, 9 October 2017. 6.3, 2 April 2018. 6.4, 18 October 2018. So looking at this, we have 7.8, which is August 24. So chances are 6.4 probably is going to be using OpenSSH 7.8 or later. So we're left with either 6.2 or 6.3. I'm going to guess that it is 6.3. So that is how we enumerate the BSD version, or at least just guess it from the information we have. The next thing to do, let's just poke at the web server because, well, we always poke at web servers first. So let's go to 10.10.10.107, and we get nothing. So I'm going to send this over into burp, turn intercept on, refresh this page, go to burp, send this to the repeater tab, click go, and we're not getting anything back. We can try changing the request method to post request, click go, not getting anything, and it's odd because Nmap was able to tell that this was OpenBSD, and I don't know how. So what I'm going to do is let's open up Wireshark and sniff the traffic and see exactly what Nmap is doing. So Let's go here. Let's resize our Wireshark window. Scroll down. Okay. Listen on ton 0. And then we want to do the Wireshark again. So nmap-p 80 to specify port 80, and then run the same enumeration script. Let's not do any host detection. And then the port. And that -PN, that's just not going to do like an ICMP to make sure the host is alive and things like that. So if we look at Wireshark, we see the request. We can sort it by HTTP and then follow the request. And we see, look at Wireshark, we see the request. We can sort it by HTTP and then follow the request. And we see Wireshark's doing a get and then getting nothing back. So that is odd. Going back to HTTP, we can see a 400 error message gets responded by the server. So if we follow this, we see we sent it nothing. If we go to TCP stream 7, it's kind of the same thing as, oh, we set it junk and then it responded with 400 bad request. So if we go back to our window, netcat to 10.10.10.107 port 80, send it junk, that's not a valid request, we get nothing. If we just send it a blank line, it gives us the 400. Request back. So we can also emulate that in Burp Suite, send it no request whatsoever, and click go. Blank line, click go, and we get 400 bad request. So if we send like periods, like nmap did, we get that. If we send it ASCII, I think it just hangs. Send this. Oh no. So as long as it's not a valid HTTP request, we're golden. And we can get that it's an OpenBSD box. But if we can't do any legitimate HTTP request to this, there's not really anything we can do to further enumerate this until we find out more information about the web server. So let's go back into our Nmap stuff. And the next thing I want to look at is this anonymous bind OK. So